Hello everyone, welcome to Learn Online. In today's session, we'll be seeing one of the very important topics of quantitative aptitude. Yes, it is averages. If you ask me how many questions we can expect from the topic of averages, we can expect hardly one question in your placement papers. But then why am I telling that averages is a very important topic? That is because you would need to understand the topic of averages to answer a few questions on ages, ratios, percentages, partnerships, and other topics as well. So, averages is very important. So, let us see what all we'll be learning in today's session. First, we'll understand the term average. We'll see what averages mean. Then, we'll understand the concept or the logic behind averages. And then, we'll see a few problems and see how to apply the concept that we have learned. And at the end, we'll also be seeing the concept of weighted averages. Yes. Hi, I am Kanaka, your aptitude trainer. So now, you people tell me, what do you mean by averages? When I ask this question, the first answer I get from most of the students is, average is equals to sum of all observations by number of observations, which is absolutely correct. This is what we have been learning from our schooling. But then, did I ask you what is the formula for average? No, I asked you what do you understand by averages. This is where students start getting confused. Now, I would tell you, if you ask me the same question, what is average? I'd be telling you average is nothing but seeing all the observations equally, or a method of equal distribution. So what do I mean by that? Let me tell you a small story so that you can understand averages better. Let me say there's one mother. She has two children. The elder one named Kalia is well built and is huge, and his younger son, mother's younger son, Dolu, is a chotu guy. Now, mother goes to a market, buys 4 mangoes and comes back home and gives those 4 mangoes to Kalia and tells him to share it with his brother. So what does that Kalia do? Kalia is a greedy man. He takes 3 mangoes for himself and gives only 1 mango to Dolu. But then, will the mother keep quiet? No, she treats both her sons equally. So what does she do? She takes the extra mango that Kalia has, that is 1 extra mango. She'll give that mango to Dolu. She'll give that mango to Dolu. So now, how many mangoes will Kalia have? Kalia will have 2 mangoes. And how many mangoes will Dolu have? Dolu will also have 2 mangoes. So what did mother do? She equally distributed the mangoes between her sons. So this is what we mean by averages. Let me take up another example so that you will not forget the concept of averages. Let me say we have a friend, and our friend's name is Jaggu. He's a student who goes to a school, and he has written an examination, and he has scored 30, 40, 50, 60, and 70 marks in 5 different subjects. Now, if I ask you what is the average score that he has scored, what will we do? We'll use the formula first. What is it? Average is equals to sum of all observations, that is 30 plus 40 plus 50 plus 60 plus 70, all divided by number of observations, that is he has 5 different subjects, so it is 5. So what do we get? Average will be equal to 70 plus 30, 100, 60 plus 40, 100. So totally 200 and 150. So it will be 250 divided by 5. So what will be the value of my average? My average will be 50 marks. So what did I tell you? Average is also called as equal distribution. So now what do we need to do? We need to see all the observations equally. So My average here is 50. So I have to make all my terms as 50 here. How do I do that? When I look at my term 30 here, is it greater than 50 or less than 50? It is less than 50. But by how much is it less than 50? It is 20 less than 50. So what am I supposed to do? Now I need to add 20 marks to this subject. So it will become 50 marks. Now look at this term here. What is happening here? Again, 40 is less than 50 by 10 marks. So what do I need to do? I need to add 10 marks to this. Now, look at 50. 50 is equal to my average. So I'll not be doing anything to this term. Let me look at my next term here. Which is my next term or the next marks here? It is 60. Is 60 greater than 50 or less than 50? It is greater than 50. Meaning it has an extra. How much extra does it have? It has 10 marks extra. So what am I supposed to do? I need to subtract 10 marks from this. So whatever marks that I have subtracted from 60 is what I'll be giving? 40. Similarly, now 70. Is 70 greater than 50 or less than 50? It is greater than 50. By how much? 20. So I'm subtracting 20 marks from the 70 and giving that 20 marks to 30. So now what am I doing here? I'm seeing all my observations equally and distributing all the extras and the deficits that I have, so that this term also becomes 50. The marks in my second subject also becomes 50. Similarly, marks in all my subjects are becoming 50 here. So now, what can I define average as? Average is nothing but the method of equal distribution of extras and the deficits. Now, let us take up another example. You people help me with this. Now, I'll tell you, there's another friend of mine and his name is Beam. This time, Beam is a cricketer. And what does Beam do? He scores 25 runs in the first match, 30 runs in the second match, 35 runs in the third match. Similarly, 40 and 45 runs in last two matches. Now, if I ask you, what is the average of Beam? What will you do? We'll quickly write down the formula and start solving the problem. So, what will be my average? Average will be sum of all my observations divided by number of observations. So, it will be 25 plus 35 plus, okay, I've left out 30 here, 30 plus 40 plus 45. The whole divided by 5. So what do I get? 45 plus 35 gives me 80. 80 plus 40 gives me 120. 120 plus 30 gives me 150. 150 plus 25 gives me 175. So my average will be 175 divided by 5. So what will be the value of my average? It will be 35. My average will be 35. This is according to the formula. But according to the definition, what is average? It is equal distribution of extras and deficits. Now let us see. I have a 35 in the series, so I will not have to alter this 35. Now what do I need to do? I need to distribute the extras and deficits. Which all the matches have extra? 40 has extra. How much extra does 40 have? It has 5 extra when compared to the average, that is 35. So what am I doing? I'm subtracting 5 runs from here and giving it to 30, which has 5 runs less. So it will be plus 5. Now here, when I compare 45 and my average 35, what is happening? I have 10 runs more in this. So I'm subtracting. It has an extra. And when I see 25, it has a deficit of that 10 runs. So what am I doing? I'm taking this extra and giving it to the deficit one, which has 10 runs less. So what happens? All the terms in my series or all the scores of each and every matches become 35 runs. So what did we just do? We just distributed the extras and deficits equally. But then observe my series. Observe this series and this series here. Do we have anything in common? Is there anything in common that you can observe here? Yes. Look at this term 35 here. That is the average. And look at the 50 term here. It is also the average. And where is it? It is lying exactly at the center. So what can I tell from this, or what can I conclude from this? I can conclude that the average lies in the center of my series. But then, is it true for all the series? No. Why is it not true for all the series? Look at this first. Look at both the series here. What are they? They are in arithmetic progression. Now, what do you mean by arithmetic progression? Arithmetic progression is nothing but when you compare two consecutive terms. See, 30 and 40 are the two consecutive terms. 40 and 50 are the two consecutive terms. 50 and 60 are also the two consecutive terms. Now, if you take the difference between them, what is the difference between 30 and 40? We have a difference of 10 here. Between 30 and 40, we have a difference of 10. What about 40 and 50? Again, we have a difference of 10. 50 and 60? Again, we have a difference of 10. So, what does my arithmetic progression mean? It means the terms in my series have a common difference. That is, it will be the same difference throughout the series. So, whenever we have an arithmetic progression, the average of that series always lies in the center. But then can we observe anything else? Yes. Now look at this term 30 and 40. What is the mean of these two terms? Mean of 30 and 40 will be? Mean will be equal to sum of those two terms 30 plus 40 by 2. So what do we get? We get 70 by 2. That is nothing but 35 and it is the same as my average here. Now look at my first term and the last term, which is 25 and 45. What will be the mean of 25 and 45? Sum of those two. 25 plus 45 gives me 70. 70 divided by 2 gives me 35 once again. From this, what can I conclude? I can conclude that the mean of any two terms which are equidistant from the center will always give me my average. But people, be very careful here. When will this hold good? Only if the series or the terms in the series are in arithmetic progression. Only then these two conditions will hold good. So people would have understood the concept of averages clearly. Now let us see how to apply that in our problems. Let us take up a first example. That is, average of 4 consecutive odd numbers is 106. What is the third number in ascending order? So now let us quickly use the formula or the general method and let us solve it. What does it say? The average. So first let me assume my numbers to be as x. So if x is my first odd number, what is my next odd number? If my first odd number is 3, what will be my next odd number? Next odd number will be 5. How did we get that? 3 plus 2 equal to 5. Similarly, if x is my odd number, which is my next odd number? Next odd number will be x plus 2. What will be the odd number after x plus 2? It will be x plus 4. And what will be my final odd number? It will be x plus 6. Because they are talking only about 4 consecutive odd numbers here. So if we apply the formula, we have average will be equal to sum of all observations divided by number of observations. What is sum of all observations? X plus 2 plus x plus 4 plus x plus 6. The whole divided by 4. And this will be equal to the average. They have already given the average as 106. Now, what do we get the sum here? The sum will be 4x plus 2 plus 4 gives me 6. 6 plus 6 gives me 12. Divided by 4 will be 106. So now, if I cancel this out, what do I get? 4 1 times, 4 1 times and 4 3 times. So what will be the value of x here? 3 going on to the other side will become minus 3. 106 minus 3 will give me 103. So the value of x will be 103. So I've got my value of x as 103. So what will be my 4 consecutive odd numbers? It will be 103 and next odd number will be 105. Then it is 107 and 109. So now what are they asking? They're asking us about the third odd number in the ascending order. Which is the third number? First will be 3, 5 and 107. This will be my final answer. Now again, do we need to solve all this? Let us quickly apply our method of equal distribution. So method of equal distribution. what does the method of equal distribution say? In an arithmetic progression, the average always lies in the middle. There are 4 terms here, 1, 2, 3 and 4. Let me call this as my 4 terms. Where will my average lie? Average will always be in the middle. So this will be the middle and this is where my average will lie. So it will be 106 because they have given in the question that the average is 106. So if this is 106, which is the next number, it will be 107 and that is the odd number here. So which is the number before 106? It will be 105. So now what are they asking? The third number in the ascending order. Which is the third number in the ascending order? This will be my first, second and third, and this will be my final answer. This is how simple the question becomes if you know the method of equal distribution. The average of 5 consecutive even numbers A, B, C, D and E respectively is 74. What is the product of C and E? Now first, let us solve it using the general method. Let us solve it by our general method. How do we solve it? Let us assume one of our numbers as x. So they're talking about consecutive even numbers. So which will be my next even number? It would be x plus 2. What will be the next even number? It will be x plus 4. And finally, these are 3 numbers. What will be my final 2 numbers? X plus 6 and x plus 8. Now, according to the formula, what is average? Average is equals to sum of all observations by number of observations. So what do we have here? X plus 2 plus x plus 4 plus x plus 6 plus x plus 8, the whole divided by how many terms do we have? How many observations? We have 5 different observations here. So what will be our average? Average they've given it as 74. So our average is 74, which will be equal to 5x plus 6 plus 4 is 10, 8 plus 2 is again 10, 10 plus 10 is 20, the whole divided by 5. And if I am cancelling this 5 here, what do I get? 5 1 times, 5 1 times and 5 4 times. So what will be the value of x here? So value of x will be, this 4 going on to the other side will become minus 4. So x will be 74 minus 4, that will be 70. So here I have got the value of x. So which are the terms here? A, B, C, D and E, out of which x is my A. X is 70. What is B? B is x plus 2, that will be 72. What will be C? C will be 74, D will be 76 and E will be 78. Now what are they asking us? They're asking us the product of C and E. What will be the product of C and E? It will be C into E, that is nothing but 74 into 78. So now, how do we quickly multiply this? Watch our speed math videos so you can understand how to quickly multiply 2-digit numbers. So what do we have? 8 4 32, 2 here, 3 carry, 7 4 28, 8 7 56, 56 plus 28 is nothing but 84, 84 plus 3 is 87, 8 will be here, 7 7 is 49 plus 8 is 57. So the value here will be 5772. That will be our final answer. C into E will be 5772. But then, doesn't this seem very lengthy for you? Do we have to do all this to find the answer 5772? No. Let us apply the concept of ours. What did I tell? In an arithmetic progression, the average always lies in the center. Is this an arithmetic progression? Yes, it is. Why is it an arithmetic progression? Because it is consecutive even numbers. Therefore, the difference between any 2 terms in the series will be, any 2 consecutive terms in the series will be 2. So this is my arithmetic progression. So where will my average lie? Average will always be in the middle. So in A, B, C, D and E, which is my middle term? My middle term is C. And the value of C will be my average, that is nothing but 74. So if you have got 74, what will be D? It will be the next even number, that is nothing but 76, and E will be 78. Now what do we need to find out? Product of C and E. that is 74 into 78. So if we quickly multiply, what do we get? We get the answer as 5772. Now let us look at our next example so that you will understand the method of equal distribution with perfection. Now what does it say? A cricketer has an average score of 49 runs in 24 innings. How many runs must he score in the 25th innings to make his average 50? Now what do? I split it into two columns. In my first column, I'll be taking his average or his runs until 24 innings for the first 24 innings. Here it will be first 24 innings. Now in my next column, I'll take the values for the first 25 innings. It will be first 25 innings. What have they told? In the first 24 innings, he has an average. So what is the formula for average? Sum of all terms or sum of all the runs that he has scored till 24 innings. That will be sum 1 divided by number of innings that he has played. Number of innings would be 24 innings. So what have they given the average as? Average is nothing but 49. That will be equal to the total runs that he has scored till 24 innings. That is sum 1 divided by 24. So what will be the total runs that he has scored till 24 innings? It would be sum 1, that will be 49 into 24. What is the value of 49 into 24? It will be 50 into 24 minus 24. So 50 into 24 gives me 1200. 1200 minus 24 gives me 1176. So the total runs he has scored till 24 innings will be 1176 runs. Now let us look at the 25th innings or the first 25 innings in total. Now what are they telling? Now he wants to make his average to be 50. He wants his average to be 50. So what will be the total runs that he has to score in total 25 innings? We don't know. So we'll take it as sum 2 divided by how many innings that he would have played? He would have played 25 innings. So what will be the total runs that he had scored till now or till 25 innings? It will be sum 2, that will be equal to 25 into 50. So what will be the value? It will be 1250. So he would have scored 1250 runs in his first 25 innings. And he would have scored 1176 runs in his first 24 innings. So what is the runs, that amount of runs that he has scored in 25th innings only? How do we get that? We'll have to subtract the runs that he has scored till 25 innings and the runs that he has scored till 24 innings. So what do we get? 1250 minus 1176. So what do we get the answer as? It would be 76 plus 24 gives me 1200 plus 50 gives me 1250. So 50 plus 24 gives me 74 runs. Meaning he has scored 74 runs in his 25th innings. But once again, do we need to solve all this? No. Let us use the method of equal distribution. What are they telling? He has played 49 matches. So let me represent that in a pictorial way. He has played totally 24 innings he has played. He has played 24 innings and his average is 49. What did I tell you average is? Average is nothing but seeing all the observations equally. Meaning every match he would have scored 49. We'll consider that he has scored 49 in every single game till 24 innings. So till 24 innings he has scored 49. Now let me take up the 25th innings here. In 25th innings what is happening? He wants to make the average to be 50. So first he has to at least score 49. He should score at least 49 runs and then he has to think about making it 50. So now let me consider that he has scored 49 and he's still batting. He's not out, he's still batting. Now if he has to make the average has to be 50, how many runs more does he score? He should score 1 run for first match, 1 run for my second match. Similarly, he has to score 1 run for each and every match. Only then the average becomes 50 for each and every match. So till here, for every single match he has to score 1 run extra. So for totally how many matches he has to score 1 run extra? 24 plus 1, 25 matches. So in 25th innings, what is the total runs that he would have scored? First he would have scored 49 plus he should score 1 run for how many games? 25 games. So what will be the value? It will be 49 plus 25 and that will be equal to 74 runs. We get the same answer here and here, but then this method was very easy and we had less amount of calculations that had to be done. Let's look at the last example in method of equal distribution. Let us not go with the general method. Let us go directly with our method of equal distribution. Now what are they telling? A class, there are 14 boys in a class and the average age of each and every boy is 13 years. If the age of a teacher is added to them, the average age increases by 1 year. So now they're asking what is the actual age of the teacher. So how do we go about this? First let me take up the diagram. So I'll say there are 14 boys in the class and they're telling the average age of each and every boy is 13 years. So each and every boy will be 13-year-old, meaning average, meaning looking at all my observations equally. So all the observations will be equal to 13 years old. So totally how many boys are there? Totally there are 14 boys. Now what are they telling? They're adding the age of a teacher. So now there is one more person that is added. Who is that? That's a teacher here. They're telling that the average increases by 1. First let me consider that the teacher's age is 13 years. Now if I add a teacher whose age is 13 years, will the average change? No, because all the observations are equal now. But according to the question, what is happening? 1 year is increasing to each and every person in the class. If the teacher is added, the average is increasing by 1 year. So what should be the age of the teacher? It should be 13 plus 1 year for each and every person. How many people are there in total? 14 boys plus 1 teacher. So that will be 1 year for how many people? 15 people in total. So what will be the actual age of a teacher? Age of a teacher will be equal to 13 plus 15. That will be 28 years. Wasn't this very simple, people? This is how we will have to apply the method of equal distribution in our problems in averages. Let us look at our last concept for the day, which is method of weighted averages. What do we mean by weighted averages? Let me explain it to you by taking a small example. Let me say there are 2 classes, that is class 1 and another class, that is class 2. Let me tell there are 10 students in my class 1. The first class, the number of students will be 10. Let me say there are 20 students in the class 2. Number of students in class 2 will be 20. What if the average weight of my class 1 is 20 kgs? Average weight of my class 1 will be 20 kgs. And the average weight of my class 2, that will be equal to 35 kg. Now I want to combine both the classes and form another class, that is class 3. If I ask you what is the average weight of class 3, how do we find that out? We know that average will be equal to sum of all observations divided by number of observations. Now what is the sum of observations here? It is nothing but sum of the weight of class 1 plus sum of the weight of class 2. So what do we need to do? We need to first calculate the sum of both the classes. Let me take the sum of my class 1 as S1 and Sum of my class 2 as S2. So what will be sum of my class 1? How do we get the sum? Look at the same formula here. What is sum equal to? Sum will be equal to average into n going on to the other side will be average into number of students. So what is the average weight of class 1 here? It is A1. And what is the number of students in class 1? It will be N1. So the sum of weights of all the students in class 1 will be equal to A1 into N1. Similarly for class 2, what will be the sum of their weights? It will be A2 into N2 here. So now we have got both the sums. Let me substitute the values here. What do we get? S1 will be equal to A1, that is nothing but 20 into N1, that is 10. So what will be the total sum of weights? It will be 200 kgs for my class 1. So what does this mean? It means that everyone together weigh 200 kgs. So what about class 2? Class 2 will be equal to A2 is nothing but 35 into N2, that is 20. So what will be the value of S2? S2 will be equal to 700 kg, meaning totally all the students in class 2 together weigh 700 kgs. Now if I combine both the classes, what will be the new average? Let me take my new average as A dash. That will be equal to sum of weights of both the classes, that is S1 plus S2 divided by number. What number should I take? Number of students in class 1 plus number of students in class 2. That is nothing but N1 plus N2. So now what did we do here? What is the actual value average? Let me substitute here. A dash will be equal to S1, that is nothing but 200 plus S2, that is nothing but 700 divided by N1 plus N2. What is the value of N1? 10. What is the value of N2? That is 20. 10 plus 20. So value of A dash will be equal to 900 divided by 30. Cancelling out the terms, what do I get? 9 3 times. So the value of A dash will be equal to 30 kg. So this will be my new average. But then do we have to do all this? Let us understand the concept or the logic behind this. Let me say there are 10 students in my class 1. They are sitting at one corner. And there are 20 students in my class 2. And they are sitting in this corner. Now they have told that average weight of class 1 is 20 kgs and average weight of class 2 is 30 kgs. 35 kgs, sorry. So you people will understand money better than weights. So let me say every student in class 1 has 20 kgs and every student in class 2 has 35 kgs. So according to the definition, what is average? Average is nothing but equal distribution of extras and deficits. Now take the class 2. Do they have extra money or less money when compared to class 1? They have extra money. How much extra do they have? Class 1, each and every person will have 20 rupees. In class 2, each and every person will have 35 rupees. Meaning every student in class 2 will have 15 rupees extra. So what do? I first collect all the extras that they are having. So how much money will I have? I am collecting 15 rupees and from each and every person. So there are totally 20 students. So what will I have? I will have 300 rupees. 15 into 20. That will be giving me 300 rupees. Now what do? Should I run away with this money? No. I'll have to equally distribute it among all the students here. Now what is the total students that are sitting here? 10 in this corner, 20 in this corner. So totally 30 people are there. Now I need to distribute how much? The money that I have, that is 300 rupees among 30 people. So how much each person will get? Each person will be getting 10 rupees. So if I am distributing 10 rupees to each and every person, now what will the money that they will be having? Before they used to have 20 rupees. Now I am giving 10 rupees extra. So totally they will be having 30 rupees. And that is what our concept of weighted averages is. So from whatever we have done here, let us try to derive a formula. What formula that is? See, let me use this method, this one here, this equation. What do we have? Weighted average, that is A dash, that is equal to sum S1. What is the value of S1 here? S1 is nothing but A1 N1. And what is the value of S2? S2 here is A2 N2. So what will be my average weight here, or the new average? That will be A1 N1 plus A2 N2 divided by N1 plus N2. This will remain the same. Now what do? I cross multiply. I take this N1 plus N2 to the other side. What happens? A dash into N1 plus A dash into N2 will be equal to A1 N1 plus A2 N2. Now I quickly take the common terms, that is N1 is common in both these terms, so I'll take them to one side. So what will I be left out with? A dash into N1 minus A1 N1 will be equal to, if I take this N2 terms to the other side, what will I be left out with? A2 N2 minus A dash N2. Now if I take N1 common from here, what do I get? N1 will be equal to N1 into A dash minus A1 will be equal to, now I'll be taking N2 common this side, so what will I be left out with? A2 minus A dash. So now if I take N2 to the other side, what I get? N1 by N2 will be equal to A2 minus A dash divided by A dash minus A1, and this will be the formula or the backbone of weighted averages, and we'll be using the same formula even in mixtures and allegations. I hope all these concepts are clear for you. You have understood each and everything that we have solved here. We'll see much more problems on weighted averages as well as on equal distribution in our advanced courses.